Hello learners, welcome to the class. Just give me one moment if I'll check if I'm online. Alright, so today's class, what we're going to do is we're going to see concepts from, we're going to do numericals from combinations of resistors. So, hello Abhishek. So in previous class itself, we have seen what would be parallel combinations of resistors and series combinations of resistors, right? Today's class, we will focus only on numericals. Now, before we go ahead, my name is Mohana. I'm a physics educator here at Unacademy, and I'll be basically taking class 11 and 12 physics. So this is my Telegram group channel link. Any updates are there will be shared here. You can follow me through my Telegram channel, as well as this is the Unacademy ICSE and ISC board common Telegram group channel. You can follow this channel as well. Now the upcoming, just like how we have classes on the YouTube platform, right? We also have free classes on the Unacademy platform, which we call it as special classes. You can take any of your favorite educators class for free. You can engage with the educators via pull feature, and also those classes are also live classes. Any doubts you have, you can ask then and there. Now, the upcoming special class for this month for class 12, we have a class on 26th July, right? This class is on moving coil galvanometer, and if you go down to the description box and click on the link there to class 12, it will take you for all the upcoming classes. There is also a class on 30th. It will be a recap on electrostatics. So basically in that class, you can enroll for that class as well. For that class, if you have any doubts in any of the topics that are there in electrostatics, you can actually ask, okay? That class is on 30th. You can check out that class as well. Now, if you're interested in the plus subscription, these are the advantages. One is you can learn from the comfort of your home. Next is that you have, whenever you're taking a plus subscription, you're getting 4 subjects, that is physics, chemistry, math, and biology. And in the plus subscription, we will cover the entire syllabus for all 4 subjects, okay? You'll be learning from the top educators, and every 4th session, if you see, will be a doubt clearing session. So, first 2 session, whatever you're learning, the 4th session will always be the doubt clearing session. Any doubts you have in the previous topics, you can ask, right? There are many number of practice tests available. There is also every other week there is live test series. You can actually take that, and after the live test series, there will be an analysis session with the educators. The upcoming course details, I'll give it to you shortly. Now, with Unacademy, the longer duration you take a course, the price per course comes down. Now, in case if you're interested in the 6-month subscription, you have to pay 2,204 rupees per month. But if in case you're taking 1-year subscription, you have to pay only 1,653 rupees per month for 4 subjects, okay? And here, right now at Unacademy, we have the 20% off. So, till July 29th, any course that you're taking, right, say you're taking a 9 months course, you only have to pay 14,615 rupees, and you will save 2,578 rupees, okay? And if you're taking 1-year course, you only have to take 16,863 rupees, and you will save 2,975 rupees, okay? Now, in this case, you can also use my code MTIS10 to avail a 20% discount on the same, okay? Now, so the offer is only till 20th, so you can go for class 9 months or 12 months subscription if you're in class 12, and if you're in class 11, you can go for the 2-year subscription, right? Now, the ongoing batch we have for class 12 is Achievers batch. This batch started on July 6th, and the course will be taught in English. For physics, we meet every 5:15 to 6:15, Wednesday, Thursday, and Friday. So physics, I'll take chemistry, Manisha ma'am will take, Lakshay sir will take biology, and math will be taken by Rahul sir. Now, whenever you take in any plus class that you're taking, so every Monday, Wednesday, Friday, we have physics followed by chemistry followed by physics. Then on Tuesday, Thursday, Saturday, you have math followed by that class. We have biology classes, okay? Now this is going to be the 4 subjects and how it will be covered in a week, and each course is 1 hour. So even if you see in a month, normally there will be a minimum of 10 classes at least for each subject, okay? So in a month, if you see overall, there will be more than 40 classes for the entire all 4 subjects together, okay? Sometimes the class variation goes from 12 to even 13 classes per subject. Let's say physics, in a month you can have up to 12 to 13 classes in a month, okay? Likewise for each subject. Now, the Achievers batch main focus is going to be a midterm syllabus coverage, that is your term 1 syllabus coverage. After completing your term 1, we will be starting your term 2 syllabus. for class 11 also we have a plus batch. This is actually, the course name is Brahmastra, and these course also started on July 6th. For any missed classes in both, let it be in class 11 or class 12, class recordings will be given. This course will be also taught in English. Physics we meet every 5:15 to 6:15 Tuesday, Thursday and Saturday. Now if you're taking class 11 subscription, class 12 subscription is absolutely free for you guys. Okay, so if you're in class 11, you have an advantage. Now with that note, let's start today's session. So I have a simple question. If you know the answer, you can share it in the chat box of this for the same. So what do you think is, according to Ohm's law, what do you think is right? Is with the potential difference equal to current into resistor, or current is equal to potential difference into resistor, resistance is equal to potential difference times current? Which of the following, or none of the above, which of this is correct? So according to Ohm's law, right, let's say you have a resistor, and if you connect it across a battery, current starts flowing, right? Now if you connect a voltmeter across over here, you can measure the potential difference. Now this particular potential difference is proportional to current. To remove the proportionality constant, we use this constant R, which is called as your resistance. So according to Ohm's law, V is equal to IR, that is the potential difference across the ends of this conductor is proportional to the current flowing through a conductor for a particular given temperature, okay, for a constant temperature. So in this case, you should always remember Ohm's law works for a constant temperature, okay. And in this case, R is nothing but your resistance, and resistance means it talks about how much it opposes the flow of current. So resistance, from this Ohm's law, we can say resistance is nothing but what is the potential difference across the ratio of the potential difference applied across the conductor to the current flowing through the conductor. Okay, now what is the unit of resistance? Very simple. Now if 1 ampere of current is flowing, when 1 ampere of current flows, if the potential difference across the resistor is 1 volt, then the conductor is said to have 1 ohm. So resistance unit is ohms. Okay, now in any electrical circuit that you take, there will always be combinations of resistors. We may not just use one resistor, we might use 3, 4, or many number of resistors can be used. Now instead of using 2 or 3, let's say in a resistor we have such a combination, okay, or in a circuit we have such a combination of resistors, okay, or in a circuit we have, let's say, such a combination of resistor. However, the combinations of resistors are, if you can replace all of them with just one single resistor, then that resistor is called then the resistance of that particular resistor is called as your equivalent resistance for that given combination. Okay, there are two combinations in main that you need to know. One is resistors and series. So when you say resistors and series means, in this case, if you see, resistors are connected one next to another. Okay, let's say this is resistor R1, R2 and R3. Okay, so let's say this is voltage applied or across. Sorry, this is the current flowing through the circuit, right? So in this case, this is your battery, and because it's a positive terminal, so current flows in this direction over here, right? Current flowing through. Now current flowing through all of these resistors will be same. Now the potential difference, if you connect a voltmeter across each of this resistor, right, you will get a different potential drop. Okay, let's say this is voltage V, right? So let's say you connect a voltmeter here. So this voltmeter will read a potential of V1. Now across this end, if you connect a potential, this will read a potential of V2, right? And across this, if you connect a resistor, this will reach a potential of V3. Now this total potential difference of this particular battery, right, will be equal to V1 plus V2 plus V3. If you combine all them, you will get the total potential of this particular battery. Potential drop across each resistor will be equal to the total potential of this particular battery. Now the current flowing through all of this resistor will be same. In such a case, right, if you look at what is a series combination, if you see this equivalent resistance, instead of these 3 resistors, right, if you just connect one single resistor instead of all these 3 resistors, right, this resistor is your equivalent resistance. Instead of 3, you're connecting just one resistor, right? This equivalent resistor in case of series will be R1 plus R2 plus R3. In case if you still don't know how we are getting this, let me know. I'll do the derivation because we have already done this in the last class, so I'm moving ahead. Okay, now if there are n number of combination, then obviously the equivalent resistance in case of series over here, series combination, will be R1 plus R2 and so on up to Rn. How much ever resistance are there? It will be a combination of all of these resistors. Okay, so next one is, just like how we have a resistors in series, we have resistors in parallel. Parallel combination is very simple. Okay, similar only. This is voltage in this case. Now this will be R1, R2 and R3. All three resistors are connected in series, parallel, one next to another. Right, current flows in this direction and comes out in this direction. Now, if you look at the voltage over here, see, if you connect a voltmeter across these two ends, the voltage drop across each of the resistors will be same, right? Because you're measuring it against the same point. So in this case, voltage is same, right? But if you look at current, as the current I enters here, right, it gets split into into all the three branches. Different current flows through. Current through this will be I1, I2 and I3, right? And all of this current will again come back, right? This is again I1, I2 and I3, and at this junction, as it joins and come out, all this current gets added up and current I flows back into the circuit again. So in this case, current through the circuit changes. Okay, but potential difference, if you see, it remains the same. In this case, if you're taking what is the pair for the parallel combination, if you're taking the resistance value, it will be 1 by R1 plus 1 by R2 plus 1 by Rn. This will be the resistance combination, last three, right, in the R3. So in case if there are n number of resistors, then what we have is, we will have, in this case for parallel combination, you can say the number of resistance that are connected in parallel, the reciprocal of their equivalent resistance will be equal to the combination of or equal to the sum of the reciprocal of individual resistance. If there are n number of resistors, you take the reciprocal of that value and actually add them together. Then that will give you the reciprocal of the equivalent resistance. Alright, so this is again, I've given a quick overview. If you still have any doubts, you can actually ask me. Now let's see one more question. Okay, now what we have is, we have all of your questions from wherever I've taken that, the reference book details I've given below the slide as well. Alright, now let's say we have connected we have three resistors in parallel combination. Okay, now we have connected it across to a battery. Okay, and this battery has a voltage supply of 30 volts, right? So this particular battery is actually a 30 volts battery. Okay, for 30 volts battery, if you see, the current flowing through the circuit, let's say, is 7.5 amps. Okay, that's the current flowing through the circuit. Now we have three resistors, R1, R2 and R3. Okay, let's say we know the value of two of the resistors. Let's say this is a 10 ohm resistor and let's say this is a 12 ohm resistor. Okay, but we don't know what is the resistance value of this third one. How do we find it from this details that we have right now? Okay, so very simple. First of all, we can actually find, when you, instead of these three resistors, if you use one single resistor, what will be that value? That value is your equivalent resistor. Now from Ohm's law, okay, so see, very simple. Instead of these three resistors, if we just have one single resistor, right, that value, that single resistor value will be your, this is in parallel combination, right, effective resistance, right, this is your equivalent resistance. And in this case, we know this particular circuit, instead of these three, we can use an equivalent resistance. In this circuit, we know current I is flowing through the circuit, and in the question itself, it is given as 7.5 amps. And we know the voltage for this battery is 30 volts battery. This part we know because it is in the question itself. Instead of these three resistors, we are using one single resistance value. Okay, so from here we can say V is equal to I into R, right? So for this circuit that we are seeing over here, right? So RP, this is your equivalent resistance we have in this case. So from here, if you see for the parallel combination, what is the equivalent resistance value? That will be V by I, right? So voltage in this case is 30 volts. Current through it is 7.5 amps, right? So your equivalent resistance, if you actually solve for the same, you will get a value of around 4 ohms. Okay, so this value is 4 ohms. Now to find what is the resistance value of R3, now we can make use of the combination, right? The parallel resistors, when they're connected in parallel, what will be their value? We know 1 by Rp in this case will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. We know this. We know the value of Rp, R1 and R2. We can just substitute the same. Rp, in this case, this is your equivalent resistance in parallel combination is 4 ohms, which is equal to 1 by, right, R1 we know is 10 ohms, 1 by R2 is 12 ohms, 1 by R3 is what we want to find. Okay, so here what we can do is, actually we can just cross multiply, right? So if you cross multiply in this case, you will actually get, let's do this part over here, right? Alright, you can actually do these two. If you cross multiply, you will get 12 plus 10, right, divided by 120 plus 1 by R3. 12 plus 10 is actually 22. Right, 12 plus 10 is 22 over here. Okay, so we can actually make use of, if you take the 2 times table over here, we'll get 11 and 60. So this effective combination becomes 11 by 60. Right, okay, so this value over here, what we are seeing for these two values together, what we are seeing is 11 by 60. Okay, this is 1 by 4. Now, from here what we'll do, we'll take 1 by R3 this side, take the other two to the other side. This will be 1 by 4 minus 11 by 60. Okay, again we can cross multiply in this case. So this will be 60 minus 11 divided by 60 into 4. Okay, so 1 by R3 is this value. So if I want R3, okay, this is 1 by R3. If I want R3 out of this, right, R3 will be inverse of this value, right? We can just cross multiply. So that will be 60 into 4 divided by 60 minus 11. Alright, so this value if you take over here, what we will get is 60 times 4 will give you somewhere around 240 divided by 60 minus 11 will give you a value of about 49. Okay, sorry, 60 minus, my mistake, this will be 44. 11 times 4, this will be 44. My mistake over here, this will be 11 times 4, 44, right? 60 minus 44 will be 16. Okay. Now, 16 goes 16 times, if you take 16 times 15 gives you 240. So, the R3 value over here, if you solve for 240 divided by 16 means, you will get a value of about 15 ohms. Okay, that is the third resistance value. Okay, so this is one question. Again, if you have any doubts, you can ask. Right, guys, just give me one more second. All right, now let's see, let's say we have a circuit, and let's say the battery over here, okay, right, let's say in this case we have a current flowing through a circuit, and this particular current flowing through the circuit is 0.5 amps. It goes from positive to negative. When 0.5 amps current flows through these two resistors R1 and R2, right? When these two resistors, okay, the potential difference, if you take a voltmeter and connect it across the ends over here, this voltmeter is actually reading a voltage of about 12.5 ohms. In series connection, we said the voltage drop across these two resistors, if you add them, that should give you the total resistance. So voltage drop across these two resistors will be, what is the battery voltage over here? 12.5 volts. Okay, now we know this, right? Now from here we also know, okay, right, so this is what we're getting in case of a series resistor, right? Now same resistor, okay, current through, now the same resistor, what we're going to do, R1 and R2, we are going to connect it in parallel. Now what we are going to do is, the potential difference between its Hence, we are making sure that potential difference V becomes 6 volts. Okay. So, if it becomes 6 volts means in this case, we are increasing the current to the circuit to be around 1.5 amps. Okay. Initially, the current through the circuit was 0.5 amps and it was in series. Now, what we did? We are actually changing the current, right? What we are doing? We are changing the arrangements such that the voltage drop across these two ends is 6 volts. So, it's connected across to a 6 volts battery, and we can say the current through it is increased to about 1.5 amps. Alright. Now, in this case, what is the value of these two resistors? R1 and R2, what is the value we need to find? Okay. Okay, let's start with the series combination. Okay. Series combination, in this case, what we know? We know V is equal to 12.5 volts. We know current is also equal to 0.5 amps. Right. Now, in this case, we know V is equal to I into R. R is equal to what? V into V by I. This value we know. Right. But R in this case is if instead of these two resistors, if you replace it with one resistance, that is your series, that will be your series, right? That will be your equivalent resistors in series. For equivalent resistors in series, it will be sum of these two resistors will give you the equivalent resistors, right? Your equivalent resistor will be sum of the individual resistor. So, this value will be equal to V by I, right? We know that V1, right? V is nothing but 12.5 volts by 0.5 amps. So, 12.5 by 0.4 gives you 25 ohms, right? So, R1 plus R2 is equal to 25 ohms. That is one value that we have. Next, what we have is in this parallel combination, instead of these two, if we use similar case only, instead of these two, if we actually use V is equal to IR, so R will be V by I. In this case, for parallel, RP will be 1 by R1 plus 1 by R2. Now, you can do, sorry, this is actually 1 by the effective resistance combination in parallel. Right, what we are going to do? We are going to do a very simple simplification. We will actually take 1 by Rp to be cross multiply R2 plus R1, right, divide by R1 into R2. I have just cross multiply. This will give you 1 by Rp, right? If you want Rp, we just have to take the inverse, right? Or you can cross multiply. That will give us R1 R2 divided by R1 plus R2. This is your Rp value. Let's substitute the same over here. This particular Rp value we have is nothing but V by I, right? And V by I, what did we see? What V is in this case is 6 volts by current through it is 1.5 amps, right? So, this will give us 4 ohms. That is R1 R2 divided by R1 plus R2 is equal to 4 ohms, right? Now, from here we can say R1 R2 is nothing but 4 into R1 plus R2, right? R1 R2, we know what the value of R1 and R2 is, right? 25 ohms. We have seen this in the previous case, right? R1 and R2 has a value of 25 ohms. So, this will be 4 into 25. 4 into 25, in this case R1 R2 has a value of 100. Okay. Now, we are going to do a very small approximation. Okay. What we are going to do is, we are going to say that, right, we are going to do R1 minus R2 the whole square. Okay. So, R1 minus R2 the whole square, you can express it as one form. Okay. So, you can say this is R1, right, this is R1 square plus, right, R2 square minus 2 R1 R2, right. Now, what we are going to do is, for this particular value, we know this R1 R2 has a value of 4. Okay, what we can do is R1 plus R2, instead of doing this, we will take a even more simpler approximation. This particular value is equal to R1, right, plus R2 the whole square minus 4 R1 R2. Why? Very simple. We know this value, if you expand, you will get R1 square plus R2 square minus 2 R1 R2. Sorry, this is positive, right? Plus 2 R1 R2 minus there is this term 4R1 R2 over here. So this will become R1 square plus R2 square minus 2R1 R2. This value is equivalent to this value over here. So we have made this into this assumption that we are taking. Okay, so from here we know what is the value of R1 plus R2, right? R1 plus R2 was found to be 25 ohms. Okay, so 25 square minus 4R1 R2, 4 into R1 and R2, we found the value to be 100 ohms. So 25 square, when you're doing very simple approximation you can do is 225. Very simple. You can use a short trick. When you're squaring numbers ending with 5, you will get the answers in two parts. That is, last part you can do 5 times 5, that is 25. So whenever you square a number ending with 5, last part will be 25. For the previous part, you can take this first tens place value, that is 2, and add 1 to it. It will be 3. So then multiply these two numbers. Take the tens place value, that is 2 over here, add 1 to it, 3. 2 times 3 is 6. So 25 times 25 is actually 625, right? It will be 625 minus 400. 4 times 100 is 400, right? So in this case 625 minus 400. So 625 minus 400 will be 225. Okay, so this is for R1 R2. Okay, this is for R1 minus R2, the whole square. So take the square to the other side, you have to take square root. So R1 minus R2 will be square root of 225. Square root of 225 is very simple. 15 square is square root of 225. Okay, so that gives you 15. Now we have two equations. One is from here that we know R1 plus R2 is 25. Okay, so let's do that. R1 plus R2 is going to be 25. Okay, then we know R1 minus R2 is somewhere around 15. Now we have two equations. You can solve for this, right? Add the two equations. If you add them together, you get 2R1, R2 cancels, is equal to, in this case it will be 40. Alright, so you get R1 to be equal to 20 ohms. So one of the resistors value is 20 ohms. Okay, now the next is you can actually substitute in any one of these, right? R1 plus R2 is equal to 25 means, right, 20 plus R2 is equal to 25. So R2 in this case, because R1 value is 20, 20 minus 20, right, 25 minus 20. So R2 has a value of 5 ohms. So one of the resistors value is 20 ohms and the other resistor value is 5 ohms. So one resistor value is 20 ohms, another one was 5 ohms. Okay, so these are the resistor combinations that we are, these are the resistor values we can see. Alright, okay. Now with that note, let's go to the next question. Next, what we are seeing is we actually have a circuit where this resistor values, let's say the whole circuit is connected across a 16 volts battery. Okay, then if we look at the resistor value for each of this resistance over here, let's say this is 2 ohms. So this is also 2 ohms. Okay, let's say this is 8 ohms though, right? Let's say this is 4 ohms and this is 2 ohms again, and let's say this is 2 ohms again. Now let's say this point over here, let's say this point where all these three resistors are joined as point A. This point over here, these three resistors are joined as point B. Okay, now what we are going to do, alright, what we are going to do is we want to find what is the current through this particular, let's say across this 4 ohms resistor, we have actually connected a voltmeter. We want to see how much the current through this circuit is. Okay, now if you see in this whole circuit, right, this particular circuit is in series combination. This value and this value is in series combination. So let's take this as R1, R2, R3. So resistors and series combination means this will be R1 plus R2 plus R3, which means this will be 2 plus 4 plus 2. So your series combination, you will get 8 ohms across this. Now if you see if you go draw an equivalent circuit for this, you will have a circuit for about 16 ohms, right? Okay, and in this case, right, so in this case, this here you have another 8 ohms, right? So this is 2 ohms again, this is again 8 ohms, and this is again 2 ohms. Now across this only, across these three resistors, since they are connected in series, we added them. That series resistor, we got the value as, let's say RS, this value is again 8 ohms. Now if you see across the point AB, right, these two resistors are connected in parallel. So if they are connected in parallel, then again we can take parallel combination for those both, right? So let's say this is, let's say this one in this case is R4. Okay, so for the parallel combination, we have to take 1 by R4 plus this is your 1 by resistors in series combination, what we got, right? So again this will be RS plus R4 divided by RS R4, right? This is 1 by RP. So RP will be, take the inverse of the same, right? Okay, and substitute the value, both are 8 ohms only. 8 times 8 is 64, 8 plus 4 is 16. So 16 goes 4 times, right? So instead of these two resistors, right, we can just use one single resistor. Instead of using two resistors, we can use one single resistor value of 4 ohms over here. Okay, now if you see the, in this form over here, we have three resistors that are actually connected one point to another, right? So in this case, if you see, we have three resistors connected one next to another, right? So this is in series combination, right? So here again for the equivalent resistors, right, you can say equivalent resistance will be sum of all three resistors. That is, in this case we have a, okay, in this case we have a 2 ohms resistor, 4 ohms resistor and a 2 ohms resistor, which is equal to an 8 ohm resistor. Alright, so this is your, in total, instead of using all of these, instead of using so many resistors in combination, you can simply connect this 16 volts battery, right, across to one single resistor which has a resistance value of about 8 ohms. Now, you know what is the voltage in this case? You know what is the resistance in this case, right? So from here you can find what is current. V is equal to IR, right? In this case, equivalent resistance. So I will be V by R. So equivalent resistance is 16. Sorry, the current through, in this case, if you see, this voltage is somewhere around 8, right? So current is going to be 2 amps, right? This current through the circuit, this circuit will be 2 amps. Okay, so because we have calculated this for the equivalent resistance, right, what was the purpose of actually finding the equivalent resistance is to find the current value over here. Once you find the current value, we can actually say, now if you want to know what is the voltage rating across this across this resistor, we have the resistance value. Now we have to see how much current is flowing through this point. If you have to know what is the current flowing through, it is not given in the question. So first we have to find the equivalent resistance and find what is the total current flowing through the circuit that we actually found right now. Now that we found the current through the circuit, that is around 2 amps, right? Now in this case, let us actually find the, let's find what happens to the current in this case, right? So current through here, it starts here, right? This current I, as it flows over here, in this point A, it gets separated into two branches, right? The current that is flowing at this branch is 2 amps. As it flows into these two branches, now here current I1 flows and here current I2 flows. So this total current is divided into two different branches, right? So whatever the current it is dividing it into, right, in these two branches, it will be equally divided. So 2 amps of current is there, means 1 amp flows into this branch and 1 amp will flow into this branch over here. Okay, so 1 amp of current goes all the way through, comes out over here, right, to point B. So this is going to be your I1. Now I2 will flow across this resistor and you will reach the resistor I2 over here. Now these two I1 and I2 will again join together and again a 2 amps of current will flow in this case. But I1 is 1 amps and I2 is 1 amps when they get divided in this branch over here. Okay. So if 1 amp of resistor, 1 amps of current is flowing in this case over here, right? If 1 amps is flowing, right? Then in this case, if you see across this resistor in a series combination, current flow through all of these three resistors is going to be same. So 1 amperes of current is going to flow through all of these three resistors. So this is 4 amps. Now the voltmeter reading, if you want to find, we know V is equal to I into R, right? Now this will be I into R, means in this case we are looking at the resistor value R2. Current through is I1. I1 is 1 amps of current into the resistor value over here is 4 amps. So voltage is going to be 4 volts we will see across this point. Okay. Similarly, instead of connecting the voltage at this point, if you are actually connecting the voltmeter across this resistor, and if you want to see what the current through this resistor will be, then in this case V is equal to let's say this resistor value is R4. Okay. V is equal to I into R, but current flowing through it is I2. Resistor value is R4 that we have taken. I2 current is 1 into resistor value, in this case R4 is 8 ohms. So in this voltmeter what you will see is 8 ohms. Okay. Now instead of that, if you are connecting a voltmeter across this end, if you want to see what is the current through the circuit, very simple. Again here also V is equal to I into R. The current flowing in this case is 2 amps of current, because here the current or both the current join. So in this junction, in this arm over here, right, in this branch over here, the total current 1 amp plus 1 amp, 2 amps will flow in this case, right? This is 2 amps into the resistor value is 2 amps. So voltage over here, voltage drop will be 4 volts, right? So all three cases we saw what will be the voltage drop across. Okay. Now let's try and do some more questions. Okay. Let's say we have a circuit like this. Instead of this, let's say we have a circuit Alright, let's say we have a circuit where we have two resistors joined here. Okay, and across this end over here, let's say we have one more resistor. Okay, and let's say these two arms ends are joined. Let's say these two ends are also again joined. Okay, and across this, let's say there is one more resistor, and let's say we are connecting an ammeter. We always connect ammeter in series. That's when it can read current, right? So from here, we want to see. Alright, we are connecting it to a battery. Let's say the battery is a 10 volts battery. And let's say this is a 5 ohms resistor. Let's say this one is actually a 10 ohm resistor. This is again, let's say in each of the branch over here, the resistance value is 10 ohms. And across we have 5 ohms resistor, and we know voltage in this case is 10 volts. Okay. Now all we want to know is what is the ammeter reading. What will be the ammeter value that we can see in this ammeter if you're connecting it across. Why you're connecting in series is, in series we know whatever current is flowing in a series combination, we have seen the total current flows through the combination, right? Current doesn't get divided in series combination. That's why to this entire circuit we are connecting the ammeter again in series, so that the entire current that is flowing in the circuit flows through here. That is what we want to find. Now this is the circuit given. So in this case we have to find the equivalent circuit in each cases. See, if you see these two resistors over here, this resistor and this resistor, these two are connected across to the positive terminal. And these two resistors over here are connected across to the negative terminal of the battery. So, what we can do, instead of these two resistors, we can replace it with one single resistor, with two resistors. That will be something like this, right? Okay, so let's say this is one 10 ohm resistor, this is another 10 ohm resistor. See, from this end, from these two ends over here, it is connected to the positive terminal. So from these two ends, we are actually connecting it to the positive terminal. Okay, similarly the other end, if you see, right, these two ends are connected to the negative terminal, right? So we're going to connect these two to the negative terminal over here. Okay, so that's what we have done in this case. So these two terminals to the positive end, these two terminals to the positive end, these two to the negative, these two again we have connected it to the negative, alright, and in between these all four are joined, in between all four are joined. Okay, then across these two ends and across these two ends, that is joining all four resistor, we have a 5 ohms resistor value. Okay, so across here we have a 5 ohms resistor, right? And again across here we have another 5 ohms resistor. Alright, this is your equivalent circuit. So let me just erase this, so we have only one set. Right, so all of this circuit, you can finally, from this circuit, you can actually get this circuit what we are seeing right now. Okay, now this is your 10 volts battery. We know across this end one resistor is connected. This is around 5 ohms. And across over here another resistor is connected. This is again 5 ohms, and there is a voltmeter over here, there is an ammeter connected over here, through which we want to see what is the current through the circuit over here. Okay, now from here what we can see these two resistors are in parallel combination. These two resistors and these two resistors are in parallel combination. So their equivalent resistance, if you're taking, that will be 10 into 10 divided by 10 plus 10. So we know how we got this, right? Very simple. Let's say R1, R2. So 1 by Rp will be 1 by R1 plus 1 by R2. Again rearrange R1 plus R2 divided by R1, R2, right? This is 1 by Rp. So from there Rp will be, take the inverse, right? R1, R2 divided by R1 plus R2. That's what I've done. Multiplied these two resistors and divide by their terms, right? So this will be 100 divided by 20, that will give me 5 ohms. So instead of using these two 10 ohms resistor, we can use a one single 5 ohms resistor, right? So for these two resistors, instead of these two of them, we can simply use one 5 ohms resistor. Similarly, this side also is 10 ohms, right? So instead of using these two resistors, this side also, we can simply replace this with one single 5 ohms resistor. Now, if you see this combination over here, these two resistors are in series. For series combination, we can just add the resistor value. So instead of these two resistors, we can just connect a single 10 ohm resistor. Instead of these two of them, we can connect a single 10 ohm resistor. Okay. Now if you see, we have three resistors in parallel combination, right? So if you have three of them in parallel combination, in this case, then we have to take, right, in this case we can actually take the, we have to find the parallel combination value for all of these, right? So this case, if you see, the final equivalent resistance you want will be the parallel combination of first resistor, 1 by 5 ohms by 1 by 10 ohms plus 1 by 5 ohms, right? So here what you can do, a simple way if you want to calculate means 1 by 5, 1 by 10 you can keep it, 1 by 5 plus 1 by 5 will be 2 by 5. Now this 2 by 5 you can multiply by 2 and multiply numerator and denominator by 2, right? So you'll get 1 by 10 plus 4 by 10. So now denominators being same, this will be 10, 5 by 10. 5 by 10 is nothing but 1 by 2. That is nothing but 1 by the equivalent resistance. So equivalent resistance, if you want, take the inverse, 2 ohms. So instead of using all of these three values, right, you can simply connect one equivalent resistor of 2 ohms. Connected a meter across, right? And across here we have a 10 volts battery, right? This is the current flowing through the circuit. Okay, and now from here, let's say this is actually a 20 volts battery. Now from here we know V is equal to I into R, right? I is nothing but V by R. V is 20, R is 2. So current value will be 10 amps. So this voltmeter will read a current value of 10 amps, right? It will read a current value of 10 amps. Alright, so with this note, let's see one more question before we end today's class, right? Okay, so in this case, alright, so let's say we have a circuit, something like this. Let's say there is one resistor across these two ends. Okay, across this there is one more resistor connected. Okay, let's say this point is C, this point is B. Now you're doing the entire connection across P and Q points over here. Okay, now from here, let's say all of these three, right? All of these three are 1 ohms. Okay, now from here, if you see, there is going to be one more resistor combinations, right? Like the similar way we have over here. Let's say all of these are also 1 ohms. Okay, let's say this point be A, B, C. Okay, now we want to find what is the equivalent resistance for this entire circuit along this point P and Q. Each resistor has a value 1 ohm. Okay, so initially if you look at any parallel two arms, see this arm and this arm are parallel, right? These two are parallel, these two are parallel, these two are again parallel. Now instead of this parallel combination, we can actually find what will be the instead of these parallel combination, what we can use, right? Let's say this is R1, R2. R1 and R2 are in parallel combination, right? So for this case, the parallel combination that we are taking, this will be 1 by R1 plus 1 by R2, right? So if you want Rp, that will be R1, R2 divided by R1 plus R2. So this will be 1 into 1 divided by 1 plus 1. So this will be 1 by 2, right? Or 0.1 by 2 is 0.5 ohms. So instead of using these two resistors over here, what we are seeing is instead of using these two parallel arms, we can actually substitute it with one single resistor. Okay, let's say this is point B, point P, and let's say this is point P. Instead of this resistor and this resistor, these two resistors, we can use one single resistor. Okay, that is around 0.5 ohms. Let's say this point is A. So you can use one single resistor. Let's take it as R1, 0.5 ohms. Okay, now what we can do, similarly for the other two parallel arms also. You have two parallel arms here. If you actually take the equivalent resistance in this case, because this is 1 ohms, just like this will also be 0.5. Okay, this in this case will be point C over here. Between these two over here, right? Because these two are equivalent to each other, right? So if you see these two over here, these two arms are equivalent to each other, right? So their resistors value, as we have seen in the previous class, this also will be 0.5 ohms again, right? This point is Q. So we have converted from here to this equivalent circuit. Okay, now if you see what is the equivalent circuit, now these 2 points are actually in series, right? So across these 2 points, if you're taking, these two are in series. So instead of using these two resistors, we can simply take one resistor. But since let's say this is R2 and let's say this is R3. Now because it is in series connection, we have to just add these two values, right? That will be 0.5 plus 0.5. So R3 in this case will be, the series combination you're taking will be 1 ohm. So finally what we have is across these 2 points, right? We have one resistor, okay, and then we have another resistor across this point over here. This is across PQ let's see, this is B and C. Alright, so in this point over here, this resistor value is 1 ohm. Now this resistor value is given as 0.5 ohms. Now instead of these two, if you want to find what is the equivalent resistance, then we have to do, these two are connected in parallel. So in this case, we will again, for parallel combination, we will have to again add them together, right? So finally, the equivalent that you want is in the parallel combination. That will be 1 by R3 plus 1 by Rs, right? So if you want that, this equivalent combination is going to be R3 into Rs by R3 plus Rs. R3 is what? In this case 0.5 into 1, alright, by 1 plus 0.5. So this value, let's see, in this case this value is what? 0.5 by 1.5, right? That's around 5 by 15, right? 5 by 15 is nothing but 1 by 3. The value in this case is 1 divided by 3. 1 divided by 3 has a resistor's value. If you're taking the equivalent resistance, it will be 0.33. It will be recurring. You can take 0.33 ohms. That will be the value of the equivalent resistance. So if you're connecting all of this as 1 amps around this, in this structure, instead of all of these connecting so many, you can just connect one 0.33 ohms resistor. Alright, so with this note, we are almost towards the end of today's class, right? Okay, so before we end, we will do one more simple, very simple question. So if you have any question, you can ask me over here. Let's say we have one resistor which is 2 ohms. Let's say this is connected across this, let's say this is basically connected across to another resistor, right? Let's say this is another 1 ohm resistor, this is another 1 ohm resistor. Across these ends AB, we want to know what is the resistor, what is the equivalent resistor across this. Okay, very simple. These two are in, let's say R1, R2, R3. These three are in parallel combination. So parallel combination is in R2 and R3 is in parallel combination. So RP, if you want, you have to do R2 into R3 divided by R2 plus R3, right? So that will be 1 times 1 divided by 1 plus 1, that is 1 by 2. So the effective resistance in this case is just 0.2 ohms, right? So instead of this circuit over here, we can say I can use just a 2 ohms resistor. This is your R1, and instead of this entire combination, you can just replace it with a, this case, this is in case of the parallel, right? Instead of this entire combination, you can just replace this entire thing with a 0.5 ohms resistor. Now, these two are in series. If these two are in series over here, then we have to add them together. Alright? This will be 2.5 ohms. This will be your resistor's value. Okay, this will be, instead of these three, you can simply use a 2.5 ohms in the circuit and you will get the same answer. This is your equivalent resistance in this case. Alright. So with this note, we are coming towards the end of today's class. Once again, at Unacademy right now till July 26th, we have the ongoing offer we have is 20% off you're taking for any plus subscription that you're taking. Let it be class 9, 10, 11, 12, doesn't matter, any ISC board subscription you're taking. If you're taking for a duration of 9 months and above, then you can get 20% off if you're using the educator code. And in case of 9 months for class 12 students, if you're taking a 9-month subscription, you can actually get 14,615 rupees is the price you need to pay right now to before 20, if you're taking before 29, right? And you'll be saving 2,578 rupees. If you're taking 1 year subscription, you only have to pay 16,863 rupees and you're saving around 2,975 rupees. Okay. Now, you can actually, to avail this 20% discount offer, you can use my code MTIS10. Alright. And also, in this case, if you see, okay, In this case, right, if you whatever subscription you're taking, let's say you're taking 1 year subscription and you're paying 16,863 rupees. Okay, so this amount, because it is for 1 year and above, you can pay in installments, and there is also a zero cost EMI available. And as well as this amount that you're paying is for 4 subjects: physics, chemistry, math and biology. Okay, now the ongoing plus batch we have for class 12 is the Achievers batch. This batch started on July 6th. For any of the classes you missed, class recordings will be given. The class course is taught in English. For physics, we meet every 5:15 to 6:15 when Monday, Wednesday and Friday. Math, Rahul sir will take. Chemistry, Manisha ma'am will take. And biology, Lakshay sir will take. Okay. Now, in case if you are if you see any month, right, at least minimum 10 classes will be there for each subject. Minimum. There could be 12 to 14 classes in a month, but at least in a month, if you take at least 10 classes will be there. Okay. And total, you will get more than 40 classes per month. And other than this, there will be analysis session, the test series, live test series, and as well as after that, there will be analysis sessions as well. So in Achievers batch, first we will target your term 1 syllabus. After that, we will go into your term 2 syllabus. Similar for class 11, class 12 also we have a batch. This batch name is Brahmastra. So again, this is again midterm syllabus coverage. So for physics, we meet every 5:15 to 6:15, Tuesday, Thursday and Saturday. After covering your term 1 syllabus, we'll go into term 2 syllabus. Okay. Now, teachers will be the same for the educators will be the same for the other subjects. All right. Now, if you're in class 11, you have an advantage. If you take class 11 subscription right now, if you're taking for about 1 year, then your class 12 subscription is absolutely free. You only have to pay for 1 year, and you will be getting the subscription plan, right, for about 2, yeah. So you will get the subscription plan about 2 years, right? So right now, if you're taking a course for class 11, you will basically be paying per class, your amount goes below 20 rupees. Per class, you're paying only less than 20 rupees. Now, if you're taking for class 12, then the amount is somewhere below 35 rupees. Okay. So if you're in class 11, do make use of this, take this as an advantage. You are getting 1 year subscription. The second year subscription is absolutely free. Now, in case if you are, you can go down to the description box. The link to my community channel will be there. You do not have to miss any updates from any of your educators. You can also share your feedback from directly via with educators via pull feature. So what you can do is you can go down to the description box, click on the class 12 description, community link, and it will take you to my community page where there will be some questions asked from your first 5 units in MCQ types, right? Try answering them as well. Now, in case in any of the educators video, if you find anything inappropriate and if you report the same, you can claim the prize. Okay. Now, if you like the class, please share it among your friends, subscribe to the channel, and also click on the bell icon to get notification. And I'll see you all in the next class. Bye.